Welcome to 43rd lecture in the course of Industrial Engineering and Operations Research. We are discussing operations research, and in that we are discussing the topic of transportation models. It is that if you have got m number of suppliers and there are n number of destinations, and you have to transport items from suppliers to destinations. So, in what manner you should transport so that the total cost of transportation is minimized. And you may have, so you can represent the whole thing in the form of a matrix, okay. So, where your matrix rows can denote suppliers, okay, this is maybe S1, S2, S3, and destinations can be represented by D1, D1, D2 and D3. So, you are going from S1 to D1. So, S1 to D1, what is the cost of transportation? That is given to you per unit cost of transportation. S1 to D2 is also given to you, S1 to D3 is also given to you, and this how much supplier S1 can supply, that quantity is also known to you. Similarly, S2 can supply this much, S3 can supply. D1 means how much is the demand, that is also known to you, D2 and D3. So, in what manner you should transport so that total cost of transportation will be minimized. S1 makes, say, let us say 100 units, maybe optimum allocation will say that he should supply only 40 units to D1 and maybe 60 units to D3 or whatever that thing. So, it will come, we have to follow optimization procedure, but we can make the initial basic feasible solution. That means we do that, and one method I have already discussed in the last class, that was northwest corner method, where we used to start from the northwest corner, try to allocate as much as we can do in this corner S1 D1, and then we move this way or that way depending on whether you have supply remaining or you have demand remaining. So, that method is very easy, that is why it has been told quickly you can allocate like that and at least you can get a basic feasible solution. But this is naturally not an optimum one. So, much better solution can be obtained, that will be initial basic feasible solution by least cost method. If you get already a good initial starting solution, then other steps of optimization will take less time and you will get the solution in a fast way. So, least cost method is a heuristic method, by that you can see. So, let us explain that method with the help of the same example. Some special items are produced at factories at Patna, Guwahati, Mumbai and Hyderabad. So, factories have been put here, Mumbai, Hyderabad, and distributors are located at Lucknow, Delhi, Jaipur, Chennai and Kolkata. Supply and demands of items are indicated in table. You see Patna supplies 3000, Guwahati supplies 6000, and demands also, Lucknow demands 2000, Delhi demands 7000, Jaipur demands 4000. Note that these factories have capacity to produce 18,000 items. See, capacity means there are supply, Patna can supply 3000, Guwahati can supply 6000. So, together if we take this, total they can supply 18,000. However, demand is not 18,000, that is basically this one, 2,000, 7,000, 9,000, 13,000, 14,000 and 15,000. So, demand is 15,000. So, supply is different from demand. So, it is unbalanced, you have to balance it. And cost of transportation is indicated in each cell. Patna to Lucknow basically 610, you can say 610 rupees per unit. Actually it is distance between Patna and Lucknow, but I can consider that cost is also proportional to distance. Okay. So since it is unbalanced problem, therefore we have to add a dummy variable and rather dummy demand. Okay. So that because demand is less, whichever is less, that has to be compensated. So dummy station, dummy demand location where you can supply. So this is 3000. So dummy has been created so that somebody can also supply item to dummy, but that meaning will be that that company is not able to supply. So therefore instead of dummy you can say material will go in the go down of that company. And so let us come to the stepwise procedure of the least cost method. So in the least cost method you examine all the cells and you find out that which cell has got the least cost. So in this case we say Patna to Kolkata transportation takes only 580 unit. So therefore 580 is the least cost, and here you can do that, but you have to check the corresponding supply and demand. If you see that I can supply to give to 580, but demand is only 1000, supply is 3000. So naturally minimum of these two is 1000. That means Kolkata can take maximum 1000. So I can only give 1000 here. In bracket I just wrote 1000. Only that much I can give. So with that supply will reduce to 2000. That means Patna now has to supply 2000 more out of 3000. 1000 gone, and here it is 0. That means Kolkata is having now 0 demand. Okay. So I can strike that column. Okay. Kolkata column is gone. You cannot supply anything to this row. That means from Mumbai to Kolkata now nothing can be done. So therefore here it is 580 as I have said, and I strike this one Kolkata column. Now supply is remaining 2000 only, and this is of course 0. Then again in the remaining cell you find out which is the least cost. Okay. So this is the now the least cost. You can see of course the least cost was the dummy, but generally we supply the things to dummy later on and we see only these cost here. Okay. Even if you do that supply, suppose by mistake you have supplied to dummy also first, then also not a big deal, because still you will get some solution, because we are talking about initial basic feasible solution, starting guess. So it will be something here and there, that is okay. After that you will optimize it anyway, but it is better to follow the proper procedure efficient way. So therefore we will not see in the dummy cells, we will see here. So here lowest one is I think Patna to Lucknow. Okay. 610. So therefore what we will do, that in 610 we will give the maximum supply. How much? 2000 is the supply. Here Lucknow demand is also 2000. So we can say that this is 2000. Okay. So in the 2000, that now what happens, that we can strike that 2000 here. That means Lucknow's storage gone, and of course we have to strike Patna also. We can, because their supply is gone. Otherwise you make a rule that you can strike cross cut only one thing. Okay. So and one remains. So there you can, if need be, there you can supply the 0 thing. Otherwise if you cross column and row in both together, then it is possible that you may not be able to get basically allocations in total. How many rows that we need? There are 4 suppliers. So 4 plus 6 destinations including dummy minus 1, m plus n minus 1. That means I need 9 cell filled. Okay. So this is the that type of thing may happen. Okay, later. But anyway, let us strike both. Okay, let us do that type of thing. And then least unit cost is 630 in cell Hyderabad, Chennai. Check corresponding supply and demand. Okay. Now, after that least is this one. So, both were 1000 this one. So, this is no, this is 1000, least now is 630, this is 1000. So, I can supply 1000 here, but then this will remain as 4000. Okay. So, therefore, what will happen, that it will become, I gave 1000 here, it remains 4000 and it is 0, and I simply strike Chennai column. Then we have to check that where is the least cost. Okay. In the other cells, we have 1910, 1946, 1420, 1150, 1560, 1470. Out of that, 1420 seems to be least cost. Okay. So, therefore, we will try to allocate maximum this to this, but here supply in this cell, Mumbai can only supply 4000, although Delhi can accommodate 7000. So, maximum we can give 4000. Okay. Let us see here. So, this is no, it is that in this 1420, 1420 was not the least, rather 1150 was the least. Okay. We have to see carefully all the column, 1910, 1946. So, 1420 is not the least cost. Okay. Least cost is in fact 1150. Okay. So, that means we can, so 1150 means Jaipur demand is 4000 and Mumbai can supply 4000. So, we can maximum give 4000 and we can strike both the columns. Ideally, only one column, let other should remain, so that we can give 0, but here in the solution we have cut this one, that is also okay. Then later on you can assign extra this thing. So, here we give 4000 here, and this we strike Jaipur also, and here we have struck Mumbai also, both have been cut. Okay. So, that means now it is this one. Now, in the remaining one, remaining what are the unfilled, 1910 and 1560. So, that means we can give to 1560, that Hyderabad, this is the lowest. So, that means here I can give 4000, although Delhi has demand of 7000, but Hyderabad can supply only 4000. So, in Hyderabad row 4000 if we give, this will become 0, Hyderabad can maximum supply 4000. Okay. So, we give that 4000 here, 1560 4000. So, remaining Delhi needs 3000 still more, and then here that this is done and this is this one. So, since it needs 3000 more, so therefore, what happens, that maybe that now only one cell is remaining, no question of you can say that is the least cost. No. Okay. It is not. So, therefore, here you just give 3000 and then you say that this is now 0. So, this is the thing, but still Guwahati can supply 6000. So, where the remaining 3000 will be adjusted, that is in the dummy, you just give 3000 dummy. So, that means Guwahati is not able to supply 3000 units, one lot it supplies to Delhi. Okay. So, this becomes basically the least cost type of thing. So, the least unit cost, as we said, is 1910 in cell Guwahati Delhi. Check corresponding supply 6000 and demand 3000. The allocation to this cell is minimum of these two, 6000 comma 3000 is 3000. This satisfies the entire demand of Delhi. So, cross cut the column Delhi and use this huge 6000 minus 3000 unit with Guwahati. So, it will use 3000 unit with Guwahati. Then what? The least unit cost is 0 in cell Guwahati D dummy. So, check corresponding supply and demand, 3000 were used. The allocation to this cell is minimum of 3000 comma 3000, that is 3000. This satisfies the entire demand of D dummy. Cross cut the column D dummy also and use 3000 minus 3000 is equal to 0 unit with Guwahati. Cross cut the column Guwahati. So, now the allocation has been made. Allocation has been made, but you see that how many cells are filled. This is how many rates are there. So, this is 1, 2, 3, 4, 5, 6, 7, only 7, but we need 9. So, that means in the two cells we may have to give that some zero or epsilon type of thing, very small number, okay, something like basically 0. So that means that will be a basic variable but with 0 value. So you can decide, again you can say among the unfilled one, I can give that, I can identify 2 least cost this one cells, and in that I can assign the quantities, okay. That much can be done, okay. So that is the thing, but you know, this is among these I can see the least cost one. Say for example we have to give even 10, 20, okay. Maybe we can give that 0 quantity here, we can indicate by epsilon, and similarly we can have after that maybe 1300. So maybe we can associate epsilon here, like that we have to do that, then only it will be complete basic feasible solution. But anyway, but if it is the question in the exam is only that we have to do find out the minimum total transportation cost by least cost method, in that case you don't have to worry about whether I have to allocate epsilon quantity to some cell or not. That is not of much concern. Basically you have reached the final initial location, and initial feasible solution is this. This is 1, 2, 3, 4, 5, 6, 7. Of course that basically you have to give 2 more that thing also, but for cost calculation it is okay. Minimum total transportation cost is now 610 into 2000 and into 580 into 1000, because this is 580 is the quantity from Patna to Kolkata and the amount is 1000. So this is 1000 plus 1910 into 3000 plus you can say 0 into 3000, because dummy thing will not take anything. 1150 into 4000, 1150 into 4000, then 1560 into 4000, 1560 into 4000, 630 into 1000, and if you sum them it comes this much number, okay. So what is that thing that you know, see 1, 2, 3, 4, 5, 6, 7, okay. So that is basically 1 crore and 90 lakh, okay, because 1 crore 90 lakh, okay, 90 lakh, okay. Now this is 90,000, 90 lakh, okay. So this is equal to this one, okay, 1 crore 336, okay. So this is this one, so 90, and this is this one, okay. This one you can say unit, and then 10, no? This is 1, this is 10, this is 1000, this is 10,000, this is 1 lakh, okay, then 10 lakh, then crore, and this is the thing. So you have 19 crore, okay. That means this is so 19 crore, that means this is equal to this thing. So we got this one equal to this thing. So this is equal to 19 into 10 to the power 6, okay. That means you can say this one, big numbers you get. So therefore how to avoid that this problem? Of course I could have said that supply is only 3 or something. I could not have written big numbers and everything I would have spoken in that term. That would have also given me that thing, and later on I would have multiplied that type of thing. Similarly, if the cost is also coming in the big numbers, that also we could have done that, okay. Otherwise, so this is becoming very this one type of big number, and you have to handle and again you have to do calculation. So in order to do it fast in the exam, you can have that thing. So this is because it is like that. So you can say, sometimes you can see how many zeros are there. If you write 5 zeros in front of 1, that is 1 lakh, okay, because this type of unit in our other countries they talk in terms of millions, etc. Million means 10 lakh, but in India we talk about lakh, and this is basically we say crore. Crore is also basically Indian term, okay. So we are telling that basically it is 19 crore, because our crore, 1 crore will be like this. Okay, so this is equal to, this is lakh. Okay, this is 1 lakh, 1 into 10 to the power this one, and if I put 6 zeros, okay, in front of this one, so this will be 3 and this will be 336. So this will be basically 10 lakh, okay, or basically it will be 1 million. So we say 1 into 10 to the power 6 million. Okay, so sometimes the big numbers come, and that much big number we don't deal. So this is, but 1 into 10 to the power 6. So this will be called 1 million, or we can say that this is basically 10 lakh. Okay, because this is 50. So this is basically 10 lakh. Okay, so 10 lakh, and if you put the 1 0 more, so this will be 1 into 10 to the power 7, that will be basically crore. Okay, so this is what that this is the thing. So basically crore is basically, you can say, 10 million. Okay, so like that, if you see that here, that you have 1 2 3 4 5 6, and then you have got 7, and you have got 8. Here you have got, suppose, 3 3 6 and 7. So basically you are getting 1 into 7. So this is the thing. So it will be basically 1.90 lakh. Okay, so therefore it is 1 point, you can say 1.9, and this will be 1.9 into 10 to the power 6, or this is 19 into 10 to the power 6. Okay, so 19 into 10 to the power 6, that means 1.9 into 10 to the power 7. So you get 1.9 crore rupees. Okay, that is the cost. Okay, so that's what sometimes the big numbers may confuse you, that's why I told. But now the question is that how do I put in a systematic way the algorithm. Now I am writing the algorithm based on the book of H.A.T. Hataha. This method, so least cost method, this method finds a better starting solution by targeting the cheapest route. It assigns as much as possible to the cell with the smallest unit cost, and ties are broken arbitrarily. What is the meaning of that? There may be the situation that in two cells same unit cost is there, and those are the least, then in any one you supply. Next, the satisfied row or column is crossed out, and the amounts of supply and demand are adjusted accordingly. If both row and column are satisfied simultaneously, only one is crossed out, the same as in the northwest corner method. Next, select the uncrossed out cell with the smallest unit cost and repeat the process until exactly one row or column is left uncrossed out. So if you do this way, then you will get some cells in which there will be zero basically transportation. This means zero supply, 0 units will be transported, but they will be help this one. So what are the benefits of least cost method? You see that the same problem we did by northwest corner method, and I think we got that in the class about more than something 2 crore or something, but here we are getting 1.9 crore. So naturally the cost is less. So benefits are that this method provides better solution than northwest corner method. It is simple and intuitive, and because by intuition says that you should supply to basically cell which takes least cost and may reduce iteration in optimization. We will tell that how to optimize these things, and one method which is very popular, it is called modified distribution method, or it is called MODI method. Okay, taking MO and DI. So MODI method, so we will say MODI method, but in that it will be helpful. But limitations of least cost method, of course, it doesn't guarantee optimality, naturally that you have to optimize. So we don't know still that whether this solution is optimum or not. So this we have to do that way. And now so suppose we have gone like this, that here 2000, 2000 and something like that we have done, but we have still not allocated, you know, that here I have only 1, 2, 3, 4, 5, 6, 7. For Modi method to operate, I need complete 9 columns filled. Why? Because there are 4 destinations, so 4 suppliers plus there are 1, 2, 3, 4, 5, 6 destinations minus 1. So that means 9. So how should I give that? Maybe I can allocate here 1020 here, because that is 1018 to 1018 I can give 0, and even to 1020 I can give 0. That is the thing, because they are having the least cost, and then my things can be complete. Okay. So like that I can do that way, and this right. So this is the problem. Like that you can have number of problems. I had taken, of course, a big problem in which we had 4 destinations, and we had not 4 destinations, we had 5 destinations, okay, and 4 suppliers. And on top of that we had to add one dummy also, because demand and supplies were not matching, total demand and total supplies were not equal. But in exam you may get even a smaller problem. Let us say that this problem you can practice yourself. We have S1, S2, S3, S4, and this is D1, D2, D3, D4, okay, and this is D5, okay. This is also having 5 destinations and 4 suppliers, but thing is that supply is how much? Let us see how much is the supply. 30, 80, 110, 110 and 10 means 120, and this is 140, and demand, total demand is 10, 50, 60, 280, 420, 20. So this is balanced. So you don't have to increase one extra dummy, that thing. So in the exam this type of things will also come. It is already balanced, so no problem. And now the cost of transportation S1 to D1 is 3. You can say 3 rupees. Actually it may be 3000, it may be 3 lakh, whatever is that thing. But as I said that I am trying to avoid the bigger numbers. This is 322. So that means whatever cost will come, suppose the total cost will come 10, and if these values may be in thousands, so that means this is 3 means 3000. So if the total answer is 10, that means 10,000. Okay. Even if it is possible that you can supply also, you can say that instead of 30 you write 381, and later on whatever units you accordingly you say that multiplied by 10, or you can retain that much. This is depends on your convenience. So you can actually solve problems like this, and you can have this one. So this is the least cost method. So it is much more efficient, but of course the north west kernel, then why do we teach that basically the northwest kernel method? Because that is very simple, chances of mistakes are less, and here there are chances of mistakes are more, because you see that I may confuse, okay, sometimes that what is the least cost. Like I told in during my lecture, at one spot I said that okay, and later on so no, this is not the least cost, I didn't see that. So you have to do that thing, but once you do in a computer, then of course computer will take care about that. Anyway, to suppose this is the problem which has been given here, and cost of transportations have been given. These may be in thousands of rupees, that means 3 means 3000, 4 means 4000 per unit, 6 means 6000, or it may be in terms of the rupees, whatever is the thing. Then you have to do that by least cost method. So you have to say that least cost is 2, and but there are many places that where least cost is too many things. So what to do that? In any one you have to allocate. So in any one, that means I can allocate to maybe here, that if I can give maximum 10, because this is 10 and this is, so remaining amount will be that now this one remaining will be 70, but here I can again give that 50, because this is why 50, because 50 is the only demand. So I can give later on to this thing, then also this remains 20, and then after that here I can give 10 and this becomes 0, here I can give 20. So, I can keep seeing the least cost things and I can keep supplying, and then I can go to next section that here it was remaining. So, the least cost wise I will go to that least cost is now 4 among uncrossed 1. So, I will give that here 10, 10, 50, 10 and this is 10 and this still this 10 is remaining. Then I can see that how I can give that, okay, I think it is only this one is remaining, this is also remaining 8 and this supply is 30, okay, that means, but here, okay, so we can give 30, we can give 30 here. So, that means this goes, it is now done, okay, 0 is remaining and this is I can give here that 10, I can give 10 and this also goes and now 30 plus is 40 is this one. So, I can see that here, so I have first supply to 5, this is 10, I am showing slowly one stepwise, but otherwise in exam I can do in much faster like I have done in the previous, I just supplied here and here I have 30. So, basically you got that 30, 10 and you got 10, 20 and this one. So, here you have got and now you can calculate the minimum total transportation cost, that means 8 into 30, then 2 into 10, 2 into 50, 4 into 10, 5 into 10, 5 into 10, 2 into 10, 2 into 10, 2 into 20, 2 into 20 and this becomes 510. So, this transportation cost here has come 510. It may not be optimized, maybe it is optimum also, that we will come to know only by Modi method, but this is the thing. And let us see how many cells are filled here, 1, 2, 3, 4, 5, 6, 7. But how many we need basically? 5 plus 4 minus 1. So, basically we need 8 actually, we need 8, but here we have filled up 4, 5 and 7. Why? Because we did not really follow the instruction given by the Taha, we have cross cut, because many people do like that also. In many books you will see that they are assigning later on. So, we ended up with this problem, but now also no problem, that if you have got somebody has given you a solution like that, if some student has made and now you can say that, okay, I need 5 plus 4, rather I should say 4 suppliers, 5 destinations, 4 plus 5 minus 1, that means I need 8 basically cells filled, but here only 7 are filled. Okay. So, what to do that? Among these you can see the least one is any 2, 1. Okay. So, this is the, so I can maybe here also I can assign something, because 5, 10 and suddenly I am getting here 20. So, why don't I put here 0? I have put 0 here, 0 so unit, or if you want to avoid confusion you can say, okay, I can put epsilon unit here. So, that means now the 8 cells are filled, and which will this does not add anything to minimum total transportation cost, but it helps that in this way that it gives you total initial basic feasible solution, so that you can carry out the optimization procedure just like simplex method, and this is called a degenerate basic feasible solution. Why it is degenerate? Why it is degenerate? Degeneracy, okay, degenerate. So, it is degenerate solution because one basic variable is 0. So, this is one basic variable is 0. That means here we have a solution, that means rather I should say this is third row and this is fifth one. So, x 3 5 is basically 0, x 3 5 is 0. Other things are okay, that means other basic solutions are okay. So, other are what? X 1 1 is non-basic, it is 0. It is non-basic because we have not allocated and it is non-basic, and x 1 2 is also 0, but x 1 4 is 30. So, like that x 3 5 is 0. So, this is x11 is also 0, x35 is 0, but x11 is 0 because it is non-basic, we have not allocated anything. In x35 we are telling that we have actually allocated, but its value is 0, we have allocated 0 quantity. Okay. So, this much only for today for least cost method, and tomorrow I am going to tell one more method, that will be the final method, although there are many more methods also, but we will be stopping at that, and then we will tell after that next talk I will tell that how to optimize the solution. Okay. Thank you very much.